So we looked at this thing called a polydensity bottle. Remember that? And we had little beads in there, blue and white beads, and some kind of liquid in there. And while you just left the polydensity bottle sitting still, undisturbed, the blue and white beads were kind of in the middle. You shook it up, and the white beads went to the top, and the blue beads went to the bottom, and slowly the two sets of beads came back to the middle again. And the only thing in there, in the polydensity bottle, besides the beads, the liquid part of it in there, was water, isopropyl alcohol, and table salt. Okay, the liquid was water, isopropyl alcohol, and table salt. All right. Water can be dissolved in any concentration in isopropyl alcohol. Isopropyl alcohol can be dissolved in any combination, any concentration in water. They are said to be fully miscible. Okay? Miscible. miscible. Miscible means that you can dissolve two liquids in the other in any combination or any concentration. Okay? Well, when you say fully miscible, it's any concentration. Okay?
And one time you can dissolve
any. The miscibility usually refers to two liquids. One liquid dissolved in another liquid. And if you say they are fully miscible, it means you can dissolve them in any concentration amounts. You know, more alcohol, more water, doesn't matter. It'll be completely dissolvable of one and the other. All right, so remember that water is a highly polar substance. It's a bent molecule. Up here on the top of the oxygen, we have got it drawn here. There's a couple of lone pairs of electrons. Okay, and those lone pairs of electrons are partially negative. Or that end of the water molecule is, and the hydrogens down here are partially positive. Isopropyl alcohol can also be called propane 2-all is the way we would name it in this class. Propane 2-all. So there's an alcohol group up here, all right, and then there's a CH group, and there's a CH3 and a CH3. So this is isopropyl alcohol. So water here, and isopropyl alcohol over here. So the proper name for this, if you're going to use the IUPAC name, would be 2-propanol, but we name it propane 2-all just to be more consistent in our naming system in this class, since we're beginning to understand how to write the names of organic chemicals. All right, so water's highly polar. Well, this OH group up here is also highly polar, just like this part of the water molecule is highly polar. But the problem is that this part down here is very nonpolar. So we've got a polar part where the OH group is located, and we've got a nonpolar part down here where the CH groups are located. So overall, the isopropyl alcohol is less polar than water is. Okay, we're putting that together then with sodium chloride. And we dissolve sodium chloride in water or isopropyl alcohol, and you get sodium ions, and you get chloride ions. Okay, well, those are completely charged, not partially charged. These are completely charged. Okay? Well, which one of the two liquids, water or isopropyl alcohol, is the fully charged sodium and chloride ions likely to be most attracted to? Why water? Huh?
Because water is the only polar, is the only like double-sided polar molecule.
Well, it is the most polar overall. Water is more polar overall than the isopropyl alcohol. So the fully charged particles are going to be attracted more strongly to this particle because it's more strongly polar, more closely linked to this fully charged particle and this fully charged particle. Huh? Well, completely separately charged. Completely separately charged. Okay? So the more polar it is, the closer it is in charge nature to being ionic. That makes sense? And so this is going to be more attracted to the water and less attracted to this. So water and isopropyl alcohol can completely dissolve in each other. Water and a salt dissolve very well together. Salt can dissolve somewhat in isopropyl alcohol. But if I put all three together, the salt prefers the water because it's more polar. All right? Well, when the salt dissolves selectively with the water then, the salt water becomes more dense. And it goes to the bottom. The isopropyl alcohol goes to the top. Does that make sense? And so this is a selective dissolution here. A selective dissolving. Because charged particles are more attracted to the highly polar water molecule than to the isopropyl molecule. Does that make sense?
Which one did you say was more dense? You said the one with the water.
Well, the salt water, the water and the isopropyl alcohol are not that much difference in density. There is some difference in density. But when you put the salt in the water, that becomes way more dense than the isopropyl alcohol. And they will then separate. So isopropyl alcohol and water won't separate. Salt and water won't separate. But you put salt in water and isopropyl alcohol, the salt selectively dissolves in the water, making the salt water more dense and separating the salt water from the isopropyl alcohol. Okay? Selectively dissolving, selective dissolution, preferential dissolution. There's a lot of ways to refer to that or describe that. Okay? All right, any questions about that? So, to understand solutions, you got to understand the interaction of particles. And it was the interaction of particles we talked about a lot in the previous unit. We talked about why things become solids, liquids, or gases. Okay? So I told you in the last unit, this unit is closely aligned. The understanding of what makes something a solid, liquid, or gas is going to help you to understand how solutions work too. And here we are. Okay? If you understood the theory from unit 7, it's going to help you to understand the theory for unit 8. Because we're still talking about interparticle attractions.